Hello, my name is Steve Page. I'm the Treated Business Development Manager for Allweather Wood, and welcome to our webinar on fire retardant treated wood. This material is copyrighted under Allweather Wood, LLC. So a little history about Allweather Wood. We began our operations in 1985 in Washougal, Washington, and through the years, we've grown to 5 wood treating plants along with lumber manufacturing and distribution facilities located in California, Colorado, Oregon, and Washington. Our capabilities include high-speed incisors, custom pre-staining, various preservatives, and third-party quality control inspection in accordance with AWPA industry standards. Allweather Wood now ranks as the largest waterborne preservative-treated lumber and plywood manufacturer in the western U.S. For more information on our company, please visit allweatherwood.com for information that will include SDS sheets, preservative-treated wood safety documents, preservatives, and a current list of stocking dealers. So in this presentation, we're going to deal with applications building codes provide for the use of fire-treated wood, FRTW products, as an alternative to non-combustible materials. Through the course, we hope to be able to define the common interior and exterior applications of fire-treated wood, understand code-mandated testing standards for fire-treated wood, to confirm product properties and proper ID and quality control marks, and specifying FRTW flame spread ratings and the International Building Code requirements for those ratings, and then answer some commonly asked questions regarding fire retardants. So fire retardants, what are they? Well, basically, fire needs oxygen, heat, and fuel to burn. So fire retardants work by changing of the required elements, the fuel. By incorporating fire retardants into the wood through a pressure process, when exposed to fire, the wood releases carbon dioxide and water vapor instead of flammable gases. Fire retardants also react with combustible gases and tars that convert them into carbon char, which actually slows the fire and protects the wood from burning any further. So fire retardant formulations are proprietary, and there are few. However, they still must meet standards and certifications defined within the building codes. Third-party organizations can confirm the performance of fire-treated wood products through testing. Most commercially available fire retardants have an ICC ES report or an ESR. The ESR is the number shown on the quality mark on products and details their properties and other essential information regarding that particular brand and that particular type of fire retardant. So we have basically 2 forms of fire retardants. We have interior exposure and exterior. So we're going to deal with the interior aspect first. Interior fire retardants contain chemicals that are soluble in water, meaning that they fuse with water for uses where wood is protected from direct exposure to moisture. Common applications for interior fire retardant lumber include studs, joists, beams, roof trusses, roof sheeting, stairways, exterior load-bearing walls, and non-bearing partitions, wall sheeting, and paneling. And I did say roof sheeting. And roof sheeting is an interior application because it is covered by an applicable roofing product. So it's not directly exposed to the weather. And then there are exterior applications. These fire retardants need to stand up to rain, snow, ultraviolet light. They are formulated to withstand the effects of direct exposure and remain in the wood fiber. So traditionally, exterior fire-treated wood products have primarily been used in commercial and industrial applications, but are gaining popularity in residential applications today, especially in wildfire-prone areas as we're seeing now. Common applications for exterior fire-treated products include balconies, decks, stairways, shingles, awnings, storefronts, eaves, soffits, fascia, scaffolding, and basically anything that's exposed to the elements. But keep in mind, exterior application means above ground use only, and these are not in-ground applications. So the process. So the manufacturing process for both interior and exterior fire-treated wood products require that the material be dried after treatment. We call this KDAT, kiln dried after treatment. Most manufacturers kiln dry the material after the process. You can air dry this process, and it can be done through an air dry deal, but mostly everybody KDAZT. Building codes require that lumber be dried to a moisture content of 19% or less, and plywood be dried to a 15% moisture content or less. So testing. This is a very critical part of fire retardants. Both interior and exterior fire retardant products must meet building code mandated testing. This testing could be exterior FRT products must meet additional testing, this to establish a flame spread and a smoke index rating, which would be the ASTM E84, or the Underwriters Laboratory 73 test, place wood in a tunnel and expose it to a 4'5" flame for 10 minutes. After 30 minutes, the flame spread must not reach more than 10 feet beyond the original flame source. So there are basically 3 flame spread rating categories. And when we talk about rating categories, we talk class 1 or A. Fire retardants have a flame spread rating in this category of 0 to 25. These materials are effective against severe fire exposure and generally used in an exterior application. Class 2 or B are fire standards that have a flame spread rating of between 26 and 75. And these materials are effective against a moderate fire exposure, and they can be used as an exterior application as well, predominantly for decking and things like that, fascia. Class 3 or C fire retardants have a flame spread rating of between 76 and 200. These materials are against light exposure. We don't see much class 3 or C in the market today. Most are going to be class A or B. So quality marks. So here's some pictures and ID marks of what you're typically going to see when it comes to fire retardant products. So the International Building Code requires that each piece of FRTW lumber and plywood be labeled to identify that it has properly met the treated application for its intended use and meets the required industry standards. So if you're looking at these stamps, you're going to see that stamp number 1 from the bottom up says that it's monitored by Western Wood Services. It's Doug Fir treated plywood. It'll give you a flame spread and a smoke development of 25 or less. The other is the ICC ES report. And then the third stamp up is just a different one that shows that the material is processed through timber products. It has a UL listing, FRS, and it's treated lumber. So by looking at this, the fire retardants used in the pressure treatment process are typically colorless, although some wood appears to have the same as untreated. To tell the difference on a code-compliant FRTW stamp is used, and that's what these stamps are here. Some manufacturers will add a light colored tint to the wood, but the stamp, not the color, should be used to differentiate between FRTW and untreated wood. We do see a blue stain added to government jobs for exterior applications, and that's to let the people and the inspector know on the job that when there's a blue stain on there, it's generally an exterior application for a government application, scaffolding and roof sheeting and things like that you can't climb on a ladder and review. So here's a code-compliant FRTW stamp. This lets you know kind of what we went through on the previous slide, but this is a better documentation of what it is. So there's a brand and logo. So typically right now there are several brands out there, but we'll just take one. For instance, we'll use Drycon. Drycon is an interior brand fire retardant, and it will give the manufacturer's name and address on there. It'll give the species of wood. In this case, it's referencing Doug Fir. The drying method after treatment that we just discussed, it could be KDAT, kiln dried after treatment. The agency name and logo, which would be whatever the agency is that is on there. It could be Underwriters Laboratory or one of the other agencies that does an inspection and licensing for that particular item. The flame spread rating at 25 or less. The process report or the ES report that we just talked about. And then they have to put no increase in the listed classification when subjected to the standard rain test. So this tells me by looking at it, this is an exterior application because it had to go through the ASTM standard D2898, which is a rain test method for exposure to outdoor conditions. So IBC and fire-treated wood. reference guide. Again, WWPI, which is Western Woods Preservative, they outline the qualifications for fire retardant treatments. They do the testing requirement to confirm the protection required, strength adjustments that are required, and fastener use. This is a great tool. WWPI puts out publications that has anything to do with fire retardant or pressure treated products that comply with the building codes today. So this is something that you can download through preservewood.org or wwpiinstitute.org and use it as a submittal or just future reference guide. It'll give you options for brand names that are out there, where those brand names apply, who the manufacturers are, etc. So here's some common questions that pop up on a pretty regular basis regarding fire-treated products. So what is the standard rain test ASTM 2898 that we just discussed that appears on product quality stamps? That standard is the standard rain test. It simulates extensive exposure to the weather that includes rain and sunlight and has two methods to simulate weathering. Method A subjects the material to 12 one-week condition cycles of 96 hours of water exposure and 72 hours of drying time at 140 degrees Fahrenheit, the equivalent of 800 inches of rainfall over a 12-week period. Method B subjects the material to 1,000 hours of 24-hour exposure, featuring 4 hours of wetting, 4 hours of drying, and 8 hours of resting, with drying time at 150 degrees Fahrenheit with a continuous UV exposure. And basically what that tells you is that testing method, whether it be testing A or B, is a method and a standard that tells you that that's an exterior application product, and it's been exposed to those elements to show that it's going to stand up to standard elements that it's going to face in an everyday use application, whether it be siding, trim, beams, anything that's exposed to the elements on a regular basis. So how do I determine which fire retardant treated product is right for the job? Again, as we discussed, there's Class 1 or Class A fire retardants effective against severe fire exposure. That is, generally speaking, an exterior application. That's going to be used when you're using it for siding, trim, anything that's exposed to the elements is generally going to require a Class A fire retardant on there. And basically what that's there for is to reduce the fire exposure on an exterior application in the event of a wildland fire. So Class 2 or B fire retardants are the same thing, effective against moderate fire exposure. And then Class 3 or C is an effective against light exposure. And you may see that in an interior application from time to time. So why fire-treated wood to begin with? The number one goal for the use and specification of fire retardants is to save lives. That's the bottom line. Fire retardants and non-combustible materials are driven by building codes. Fire retardants are highly effective at slowing down the spread of the flame and reducing smoke development as a result of the fire, giving building occupants more time to escape. That's really what it's for. Usage of fire-treated lumber and plywood is trending up, especially in areas experiencing the wildland fires that we're seeing today, especially here in the western United States. It's our fastest growing key item we have in the wood preservation market, and it continues to grow in both commercial and residential and in industrial applications. Allweather Wood keeps close tabs on what the market is doing with lumber and plywood in an effort to develop new products for this important category and future use of building products. So how to store, handle fire retardant on job sites and dealer yards. Fire retardant lumber and plywood is kiln dried after treatment, as we've gone through. So Allweather Wood recommends keeping products dry prior to installation by storing under shelter or tarped or elevating units from the ground that would be ground contact and allowing air circulation around the wood. What I mean by that is don't set units directly on the ground where water can run off on them or where they're in mud and things like that. You want to keep the product dry until time of application. Job site protection. Material must be kept dry and covered until time of installation. Material will get wet during construction. Allow it to dry before enclosing. Finishing. Most fire-treated wood products can be painted or stained with good results. However, a material must be dry and clean. It's always best to check with your local fire-treated manufacturer prior to any finishing. Make sure that it complies with their stipulation on their product. So we thank you for joining us, and this concludes the Allweather Wood presentation on fire retardant treated wood.